Hello, in this second video we're going to have a look at creating M files, which are the way Matlab stores bits of code that you can execute. Those bits of code can be just normal code to repeat actions, or they can be functions, which is the type that we're going to be using. Before we have a look at M files, we need to make sure, especially if you're in the computer labs in college and you only have access to certain folders, you need to make sure that on your path, you click set path on the home window, on the home tab, and you add the folder that you're going to be using to your path. Okay, so you're going to say add folder, and you pick whatever documents, Matlab, or in your case your serial number, and then whatever folder you're using, the particular one, you select the folder, and when you close it will ask you, do you want to save it to use in future Matlab sessions? I could say yes, because I'm using my own laptop, but in your case, when you're in college in the computer labs, you cannot save into that particular folder, so you just have to say no. That means that you need to do that every single time you log into a machine. Okay, so remember, the first time, if you're going to need M files, you need to set the path and pick the folder where you're going to be saving your particular files. Okay. So now, remember in the previous video we had a look at how to use the command window to perform calculations, and we were creating some plots. Now we're going to be looking, instead of doing our calculations here, we're going to create a new script. Okay, this opens up this editor window up here. Okay, now we can use this editor window and it has some extra functionality, or you could create your file, your M file, which is the coding format for Matlab scripts. You could create them in Notepad as long as you save as .m, and that's why we call them M files. Okay, so we can start by typing some comments. Okay, the percentage symbol means that whatever comes next in this file is a comment. So I'm gonna call this my first M file, and then on the next line, if I want to continue typing a comment, I need to put again the percentage symbol. Okay, so let's say .m. This file is called, let's call it area.m, and it calculates the area of a triangle given A, B, and C. Okay, so we're saying this is going to be a function. So the first line of our file has to be function. If you type it correctly, it should change color. Okay, so you see now that I've added the proper spelling. It comes up blue. That means Matlab is understanding that this word means something. Function. Then the format is square brackets for your outputs. In this case, our output is we only have one, and it's the area of the triangle. Then equals, then the name of the file. We said we're going to call this area, or sorry, the name of the function and the file. Okay, and then in normal brackets your inputs, and we said the inputs are lowercase a, lowercase b, lowercase c. Okay, so that's our function, and we need at the end an end command that closes the function, and inside we're going to put our calculations. Okay, at the moment it's giving us warnings because we're not using those inputs, and we don't have a value for the output. So let's have a look at this line here. So we're creating a function, so we need to start with the word function, then square brackets for the outputs. Okay, I'm going to put it in a comment here. So the word function, then in square brackets are our outputs. If we have more than one, we have output 1, output 2, and so on, with commas in between. Then equals, then the name of the function, and then in normal rounded brackets we put our input 1, comma, input 2, etc. Okay, now it is really important that this name of the function is the same name as the name that you're going to use to save the M file. So before I continue creating the actual calculations, I'm going to click save, and I'm going to save these as area.m. Okay, click save. Now that name is the same as this name, and Matlab will recognize this as a function. Okay, so let's create the calculation. The calculation is calculating the area of a triangle by calculating an intermediate value S that is equal to the addition of the three sides divided by 2. And then we have the area is going to be equal to the square root of S multiplied by S minus A multiplied by S minus B multiplied by S minus C. Okay, so this is the formula, nothing to do here. Okay, now we're getting two warnings, one here and one here, because we didn't put semicolons. Okay, so usually what you want is to have semicolons in all the calculations internally of the function, because the only output you want to see from this function is the area A once you execute it. Okay, now we also see that we have a star symbol beside the name of our M file. That means that since the last time we saved it, we've made some changes. Okay, and those changes are not saved. So if I do Control S, the star disappears, and that means I have the latest version of my file in memory. Okay, so we can go to the command window down here. Okay, we can still be looking at the file, and we can say, let's say area 1 for the first triangle equals, that's the variable, that's where the output is going to be stored, and I'm going to say area, which is the name of the function here, that name goes here, and then we give it values, say 10, 12, 32. That means that 10 is the value of A, 12 is the value of B, and 32 is the value of C. Those three values go into this equation, calculate S. Those three values on S go into this equation and calculate A, and then A is returned and appears as the value of area 1. Here you go, that's my value, and there's a problem with the values I chose for my triangle. There, that's nicer. Okay, so there was nothing wrong with the calculation, just that I was doing the square root of a negative value. Okay, so the area of a triangle with sides 10, 12, 12 is 54.5436. Okay, let's have a look at what would have happened if we didn't have these semicolons here. Okay, we save it again. Every time we make changes, we need to save it, and we come back and rerun exactly the same command. Okay, so area 1 is going to be the result of calling the function area with the values for A10, B12, and C12. And what happens, I'm going to make this bigger so we see it. What happens is that when we get to this calculation internally, it calculates S, it's equal to 17, and it tells us on the screen, on the command window, what the value is. Then it moves on and calculates A here on that line, and it tells us on the screen from the result of that line. And then the value of A is returned, because it's the output, to the variable that we declared. If I go here, remember we said area 1 equals, so that's the value that the output is taken. Okay, that's your 54 point. Okay, so if we go back, we just want to know what the area is, which is 54.54, etc. So we put semicolons in all the intermediate calculations that we don't want to see results for. Okay, so if we save it again, okay, we're here, I put the semicolons again, save it again, rerun it, we just see the output. And this is important if you're going to use a function to feed another function, because you will be expecting, let's say if it was this one output, and if you don't put the semicolon, you're going to be getting, as you saw there on the screen, 3 outputs from the results of the 3 calculations, the S value, the A value, and then the real output. Okay, so get used to having on your M files, on your functions, semicolons at the end of every single calculation, and you get the output through this value here, where you have your list of all the different outputs. Okay, if we look at the exercises you need to complete for this week's submission, if we look at the function 1 in particular, we can see that we're looking for a function that takes the length, the moment of inertia, and the elastic modulus of a fixed beam, and the magnitude of the point load applied at its midpoint, and it will return the maximum positive and negative bending moments and the maximum displacement of the beam. Okay, so if we look, we have the formulas here that will give us the three outputs. Okay, and if we look at the formulas, we have the inputs are going to be P, L, those two, for those two formulas. Again, P and L. Okay, so we have P, L, E, and I. Those are going to be our inputs. Our outputs are going to be N max, N min, and displacement. So if I go back to Matlab and create a new M file, okay, so we're going to have some comments where we're going to be explaining what's happening. So we'll have name of the function, then we'll have the how to use it, inputs and outputs. This is just for the user to know what's going on with your function. Then we're going to have our word function in square brackets, the names of our outputs, remember, so we had n max, comma, n min, comma, displacement, equals the name of your file. I don't know, I'm just going to call it exercise 2. Open bracket, all your inputs, which are P, L, we've said, E, and I. You end your function, and inside you literally just have to type in your formulas. Okay, once you have it, you save it. Remember, the name of your M file has to be the same as exercise 2, and you save it, and then you can go to the command window and call it with values for those 4 variables, and that will give you 3 outputs. Okay, so let's just say, I'm not going to type in the formulas, but let's just say we say n max equals 2, n min equals 4, and displacement equals 3 or 2. Okay, so remember, here you would put the actual formula to calculate it. I'm just using this to show you how you would call it from the command window. Okay, so I'm going to save my file. It has to be called the same as the function. In this case, I called it exercise 2. You can call it any other name. Okay, so the easiest way to avoid a mistake when you're calling your function and you have multiple inputs and multiple outputs is you copy this line over. Okay, so we copy this line over, bring it here, paste, and replace. The outputs are those. We only have to replace the values for the inputs with actual numbers. Okay, because obviously the inputs, we need to give them particular values, and that's going to give us 3 outputs that are the n max value, the n min value, and the displacement value. Now, why did I copy and paste all that there? I copied and pasted that command because if I come here and I decide that this is, I write it in a different order. Oh, sorry, I need to, here, there. Okay, so using the up arrow, I bring back my latest command executed. If by accident I write them in a different order, Matlab does not know that this displacement has to be the same as that displacement. So what will happen is that the value for n max, actually I'm going to change here so we see the effect. So the first output is 2, goes through this particular variable n max, but when it gets here it will be stored in the variable displacement. Okay, and obviously all our results are going to be wrong. So the displacement is 2, the n min is correct, it's the 4, and then the n max is 5. But if you remember, that's not what was here. Okay, so the order of the outputs here has to be the same of the order of the outputs here. So this is the correct line that will give you the right values. And hence why I was telling you the safest way to run this command is to copy from here your heading of the function. That way you're sure that you're mapping the first output with the first output, the second output with the second, and so on. Okay, and then you just have to give the inputs some values. Okay, something else you might need for your exercises. Okay, when you're creating your arrays for exercise 1, you're gonna be creating some plots. You can put them all in the same graph or you can put them separate, that's up to you. But to create your x increments, you're going from minus pi, and you write it literally minus pi to pi, and if we don't say anything, it goes in increments of 1. Maybe we want to go in increments of pi over 8. I don't know, just to have a few points. Then we can calculate our sine of x, and just do it, equals sine of x. That gives you the sine of each individual value, and then you can do your plot, x comma y. That's your plot. Okay, you can see here that it looks a little bit chunky. Okay, you see there, it's not really smooth. We can change that by adding extra points into our x values. Instead of dividing by 8, say we divide by 80, that means we're going to calculate a lot more points in between. We recalculate the y and replot, and we look at the graph, and you see now the difference, how it's a lot smoother than it was. And now you're ready to complete exercises 1 and 2, and I'll set up a link for you to submit those. Okay, bye.